All right, let's look at the homework 14.2, problem number 9. All right, so we want to determine the set of points at which the function is continuous. All right, so let's look at this function. All right, so we have a function here, and this function xy over x squared plus xy plus y squared, this is a rational function. So as long as it is defined, it's going to be continuous. Right, so only place that could this is not defined would be when the denominator is equal to 0. So you can see that that happens only when x equals 0 and y equals 0, so which is the origin. All right, so the origin is the only potential problem where the discontinuity could occur. So we have to make sure that the limit is actually equal to the function value, in this case 0. Right, so let's look at that. All right, so let's try to find out this limit here. So limit of x comma y, then x squared plus xy plus y squared. Then as x comma y approaches the origin. All right. Then you can see that here we want to make sure that this is actually equal to 0. If it is, it's continuous everywhere. If it's not, then it's not continuous at the origin. So question is this equal to 0? So that's the question, right? So let's look at some path here. So let's try something like say y equals 0, right? I like setting some of the variable equal to 0 because that will simplify the expression quite a bit. Then you have x goes to 0. So numerator x times 0 is 0. And that's 0, that's 0. So you just have x squared. So you can see that this is just a limit of 0, so which is 0. All right. But if you do something like y equals x, right, so this limit becomes, right, so x times x, so x squared. You have x squared here, x times x squared, another x squared, so you have a 3x squared as x approaches 0. Right, so you can see that x squared and x squared cancel out, leaving 1 on top and 3 on the bottom. So the limit is actually 1/3. Which do not match with the other path. All right, so therefore this limit actually does not exist, which means that it's not continuous at 0, 0. Right, so f is not continuous. Right, so it's going to be, let's see, so we have to pick the one everywhere except for the origin. All right, so let's type it in. All right, click on the second one and submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.